Hi everyone, welcome back to our online video lesson. Today's topic is all about Rhombus. For today's lesson objectives, you are to enumerate the properties of a rhombus and use these properties to prove that a parallelogram is a rhombus. Let's have examples of objects that look like a rhombus. We have a traffic sign. We also have a baseball field. And it can also be a design for accessories like jewelry. Okay, so from the previous lesson, how would you describe a rhombus? Okay, it looks like a parallelogram. Very good. And since it looks like a parallelogram, it has parallel sides. Let us now try to discuss the properties of a rhombus. The first one is that it has 4 equal sides, meaning all sides are congruent. Next, it has the 2 pairs of parallel sides. So I have this first pair of parallel sides, and this is the second pair of parallel sides. I have rhombus FAIR. So the third property is that the diagonals bisect each other. So FI bisects AR and meet at point Y. So when we say bisect each other, it means that it divides either diagonals into 2 equal parts. So I have FY, or segment FY, is congruent to YI. Same thing as with AY is congruent to YR. Next, the diagonals are perpendicular to each other. When we say perpendicular, it means that they form a 90-degree angle, or what we call a right angle. So FI is perpendicular to AR. So they form a right angles on both sides, or on opposite angles, like vertical angles. Next, the opposite angles are congruent. I have angle FAI, this one, is congruent to angle FRI. Also, angle AFR, this one, is congruent to angle AIR, this one. Next, each diagonal of a rhombus bisects a pair of opposite angles. So again, when we say bisect, it divides it into 2 equal parts. So each diagonal bisect a pair of opposite angles. So for this one, we have angle F and angle I are opposite angles. Angle A and angle R are opposite angles. So if I have diagonal FI, meaning it will divide angle F and angle I into 2 equal parts. Let's see. I have angle AFI, so this one. So angle AFI is congruent to angle RFI. Same thing as with angle AIF. This angle is also congruent to angle RIF. So this is being bisected by diagonal FR. Let's have the other diagonal, AR. So meaning this diagonal will bisect angle R and angle I. Let's see. So angle FAR, this one, is congruent to angle IAR. Same thing as the opposite angle R. So I have FRA is congruent to angle IRA. All right, so we're done with the properties. Let us now try to prove some theorems that we have discussed to prove a parallelogram is a rhombus. Example number 1. Given rhombus FORD, prove that diagonal FR is perpendicular to diagonal OD. Diagonal FR perpendicular to diagonal. Okay, of course, the first statement is that FORD is a rhombus, given. Next, since this is a rhombus, we all know that FO is congruent to OR, congruent to RD, and congruent to DM. What do you think is the reason? Okay, all sides are congruent. Next, I have ED is congruent to DE or ED by reflexive property. Then we have, can say that FE is congruent to ER because diagonals of a rhombus bisect. So since we have FE and ED, or FE congruent to ER and ED congruent to DE, of course FD and DR are equal. We can say that we have two triangles FED and triangle RED are congruent to each other. By what congruency postulate? Okay, very good. It's the side congruency. Next, since we have FED and RED, triangle FED and triangle RED are congruent, we can now say that angle FED is also congruent to RED. What do you think is the reason? Corresponding parts of congruent triangles. And then we can also say that since angle FED is congruent to RED, we can say that angle FED and angle RED are right angles. Why do you think so? You see this line? The measurement of this angle is actually 180 degrees. So meaning, and since they are congruent, FED and RED, and they're congruent, and the total is 180 degrees, therefore, they have 90-degree angle each. So the theorem is that if two angles are congruent and supplementary, then they are right angles. So now we can prove that diagonal FR is perpendicular to diagonal OD. By what reason? All right, so the definition of perpendicular lines. Good job. Let's have another example. I have rhombus DOST. We are going to prove that diagonal TO bisects angle DOS and angle DTS. This is the diagonal that will bisect both opposite angles. Okay, so the first statement is that DOST is a rhombus. Of course, this is given. Next, again, since this is a rhombus, of course, line segment DT is congruent to line segment TS, congruent to line segment SO, and congruent to line segment O. By what reason do you think? Very good, because all sides are congruent. Next. So, line segment TP is congruent to PO. Same thing as with DP. The segment DP and segment PS are also congruent. The reason is that the diagonals of a rhombus bisect each other. All right. So we now have a triangle TPT and triangle TPS are congruent, also congruent to triangle SPO, and of course congruent to triangle OPD. By what reason? Very good. It's the side congruence. So now that we have angles or triangles are congruent triangles, we can now say that angle DTP is congruent to angle STP. Also, angle DOP, this one, is congruent to angle SOP. By what reason? Okay, very good. This corresponding parts of congruent triangles are congruent. Therefore, we can say that line segment TO or diagonal TO bisects angle DOS and angle DTS. By what reason? First, the definition of an angle bisector. Do you think you can do the next activity? Okay, FACT is a rhombus.